Voyager 1 is not just a machine drifting in the emptiness of space. It is humanity's most distant ambassador, a fragile probe launched on September 5, 1977, carrying with it our curiosity, our technology, and even our message to the stars. Nearly half a century later, Voyager 1 has traveled more than 15.5 billion miles, 25 billion kilometers away from Earth, at a staggering velocity of 38,000 miles per hour, 17 kilometers per second. It is racing into interstellar space, farther than any other object we have ever built. And here lies the astonishing truth. We are still in contact with it. From this unimaginable distance, Voyager 1 continues to send back scientific data, faint radio whispers that cross the darkness of space, while also receiving occasional instructions from Earth. This ability to maintain communication is nothing short of extraordinary. To grasp its significance, imagine a flashlight beam stretching across the entire width of our solar system and still being detected on the other side. That is the scale of what engineers at NASA's Jet Propulsion Laboratory have achieved. Originally, Voyager 1 was not built to last forever. Its mission was carefully designed around a unique opportunity, a once-in-175-year alignment of the outer planets. This alignment allowed the spacecraft to use the gravitational pull of Jupiter and Saturn to slingshot itself forward, gaining speed without carrying massive amounts of fuel. The images it sent back were revolutionary. The raging storms of Jupiter larger than our entire Earth. Volcanic eruptions on Jupiter's moon Io, the first active volcanoes observed beyond our planet, and the mysterious beauty of Saturn's rings, revealed in intricate detail along with small shepherd moons that keep the rings in place. After completing this historic planetary tour, Voyager 1 did not stop. It kept going, further and further, eventually reaching the edge of the heliosphere. The heliosphere is the vast bubble of space dominated by the solar wind, the constant stream of charged particles emitted by the sun. Beyond this boundary lies interstellar space, filled with particles from other stars. In 2012, Voyager 1 crossed the heliopause, becoming the first human-made object to step outside the sun's protective bubble and into the galaxy itself. What makes this achievement even more remarkable is the spacecraft's technology. Voyager 1 was built in the 1970s, with computers far less powerful than the smartphone in your pocket today. Its memory could not even hold a single modern digital photograph. Yet, this spacecraft has not only survived the harsh conditions of deep space but continues to function, sending back valuable information about cosmic rays, magnetic fields, and the density of interstellar plasma. And consider the scale of communication. A single radio signal sent from Voyager 1 today takes about 22.5 hours to reach Earth. For comparison, light takes just 1 second to travel from Earth to the Moon, and about 20 minutes to reach Mars. By the time Voyager's faint radio signal arrives, it has weakened to less than a trillionth of a watt, so weak that it would be drowned out by the noise of any ordinary electronic device. Yet, with the help of massive antennas spread across 3 continents, we are still able to hear Voyager's voice. This raises the big questions. How exactly do we hear such a faint signal? How do we send commands across billions of miles with such precision? And for how much longer will this fragile conversation with Voyager 1 continue before silence finally takes over? These are the mysteries we will explore in the next section. To understand how we are still able to communicate with Voyager 1, we need to look at the most fundamental tool of space communication: radio waves. These are a form of electromagnetic radiation, traveling at the speed of light, just like visible light but at much longer wavelengths. Radio waves have a crucial advantage: they can cross vast cosmic distances without being absorbed or scattered as easily as light. That is why, even after 47 years and more than 15 billion miles, Voyager 1's faint transmission can still reach Earth. Voyager 1 carries a 12-foot 3.7-meter high-gain dish antenna, the most recognizable part of the spacecraft. This antenna emits a very narrow beam of radio waves. But here is the challenge. The transmitter behind that antenna is astonishingly weak. At full strength, it outputs just 22 watts of power, about the same as a small household light bulb. By the time this signal spreads across billions of miles, it has weakened so drastically that what eventually reaches Earth is less than a billionth of a watt. To put that in perspective, it is equivalent to trying to detect the heat from a single candle on the other side of the planet. So how do we hear it? The answer lies in one of the most advanced engineering achievements in history: NASA's Deep Space Network (DSN). This is a worldwide system of giant antennas designed specifically to track spacecraft at extreme distances. The DSN consists of 3 primary complexes located in California, United States, Madrid, Spain, and Canberra, Australia. Their strategic placement ensures that as the Earth rotates, at least one of the stations is always in view of Voyager. This provides 24-hour global coverage, allowing engineers to maintain an unbroken connection with the spacecraft. The largest dishes in the DSN are 70 meters to 130 feet in diameter. These massive antennas are so sensitive that they can detect Voyager's ultra-weak signal and separate it from the natural background noise of the universe. Engineers use advanced signal processing techniques to pull meaningful data out of the noise. Every bit of information, whether about magnetic fields, plasma waves, or cosmic particles, is carefully decoded and stored back on Earth. It is worth pausing here to appreciate the scale. When Voyager sends a signal, it does not arrive instantly. A one-way transmission currently takes 22 hours and 30 minutes. That means when Mission Control sends a command, nearly 2 days pass before they receive a confirmation from Voyager. Imagine having a conversation where every question and answer takes almost 45 hours to complete. That is the reality of deep space communication. But signals alone are not enough. Voyager also needs power to run its instruments and transmit those signals. Unlike satellites orbiting Earth, it cannot rely on solar panels. At such a vast distance, sunlight is far too weak to generate useful electricity. Instead, both Voyager spacecraft are powered by radioisotope thermoelectric generators, RTGs. These generators use the heat from decaying plutonium-238 to produce electricity. At launch, each RTG produced about 470 watts of power. Today, after decades of radioactive decay, that output has dropped to less than 200 watts. To conserve energy, engineers have been forced to shut down non-essential systems, carefully rationing power so that the most critical instruments can continue running. Even so, Voyager's endurance has exceeded all expectations. Originally, it was designed for a mission lasting only 5 years to reach Jupiter and Saturn. Instead, it has survived nearly half a century, exploring the edge of interstellar space while still sending information back to us. So when you hear that tiny signal coming from Voyager 1, understand that it is more than just data. It is a fragile thread of connection, stretched across the abyss of space, linking our world to a machine that has traveled farther than any human dream once dared. In the next section, we will explore what Voyager is still telling us interstellar space and what these faint signals reveal about the environment beyond our solar system. Now that Voyager 1 has left the heliosphere, what exactly is it telling us about the environment beyond the sun's influence? To answer this, we need to understand what lies outside the realm of interstellar space. Unlike the relative calm of our solar system, interstellar space is filled with a thin mixture of gas, dust, plasma, and cosmic rays that originate from distant stars and supernovae. This region is not empty, but it is unimaginably sparse, so sparse that a single cubic centimeter might contain just one particle. Yet, it is a frontier of discovery, and Voyager is our only direct probe of this region. One of the most important measurements Voyager 1 provides is about cosmic rays, high-energy particles that zip through the galaxy. Inside the heliosphere, the solar wind shields us from many of these dangerous particles. But once Voyager crossed into interstellar space, its instruments detected a sharp increase in cosmic ray density. This sudden spike was the fingerprint confirming that the spacecraft had indeed left the protective bubble of the sun. Another key discovery involves plasma waves. Voyager carries a plasma wave instrument that can measure vibrations in the interstellar medium. In 2012, not long after crossing the heliopause, the spacecraft detected oscillations caused by a massive solar eruption that had traveled outward and struck the boundary. From this, scientists were able to determine the density of interstellar plasma for the very first time. Later, in 2021, Voyager detected a constant background hum of plasma vibrations, an astonishing discovery that showed interstellar space is not silent, but alive with faint, continuous ripples. Voyager has also provided data on magnetic fields beyond the heliosphere. For decades, scientists debated whether the sun's magnetic influence extended far into interstellar space. Voyager's magnetometer showed that while the direction of the magnetic field shifted at the boundary, it remained surprisingly aligned with the sun's. This suggests that our solar system may be connected to the broader galactic magnetic environment in ways we do not fully understand. Think about what this means. With technology from the 1970s, Voyager 1 is giving us our first direct evidence about the nature of the galaxy beyond the Sun. It is not just a spacecraft, it is a time capsule of human engineering, built with circuits and instruments designed before personal computers became common. Yet it continues to operate, providing insights no telescope on Earth can capture. But these discoveries are not just scientific curiosities, they have profound implications. Understanding cosmic rays helps us design better shielding for future astronauts traveling beyond Mars. Studying interstellar plasma and magnetic fields improves our models of how stars interact with their galactic neighborhoods. And by mapping the edge of the heliosphere, Voyager teaches us about the protective bubble that has sheltered Earth for billions of years. Every bit of data Voyager sends is precious, because its power supply is fading. Scientists know that one by one, its instruments will have to be turned off, leaving fewer measurements to collect. Yet, as long as even a single instrument remains active, Voyager 1 will continue to report from the frontier. In many ways, these faint signals represent humanity's first step into the galaxy. When future generations travel to the stars, they will look back and see Voyager as the scout who went first, crossing the threshold and leaving a trail of knowledge behind. In the next section, we will look at the limits of communication and power and explore how much longer this extraordinary connection with Voyager can continue before the silence of deep space finally overtakes it. As astonishing as Voyager 1's journey has been, every mission has limits. The spacecraft is still alive, but it is aging. Its power supply is slowly fading, and with each passing year, engineers must make difficult choices about which systems to keep running and which to shut down forever. Voyager 1 does not rely on solar panels like satellites orbiting Earth or probes traveling near Mars. At such great distances, the Sun is simply too faint to provide useful energy. Instead, both Voyager 1 and Voyager 2 depend on radioisotope thermoelectric generators, RTGs. These generators convert the heat from the natural radioactive decay of plutonium-238 into electricity. At launch in 1977, each RTG produced about 470 watts of power. Today, after nearly 5 decades of continuous decay, Voyager 1's power output has dropped to less than 200 watts, not even enough to run a simple microwave oven. Because of this decline, NASA engineers have gradually turned off non-essential systems to conserve energy. Cameras, which once sent back breathtaking images of Jupiter and Saturn, were shut down decades ago. Instruments heaters that once kept it some components operating at leaving temperatures far below their intended design limits. Even so, many instruments continue to function, a testament to the durability of the spacecraft's engineering. But the hard truth is this: every year, power continues to decrease by a few watts. Eventually, there will not be enough electricity to run the critical instruments or even the transmitter itself. Most scientists estimate that by the mid-2030s, Voyager 1 will fall silent, unable to send further messages. When that day comes, humanity will lose its first and oldest ambassador to interstellar space. Communication itself is also a challenge. As distance increases, Voyager's signal grows ever weaker. Right now, it takes more than 22 hours for a signal to travel one way. By the time that signal reaches Earth, it is weaker than a trillionth of a watt. Detecting it requires the most advanced antenna systems on Earth, the Deep Space Network with its massive 70-meter dishes. Without these, Voyager's voice would have been lost long ago. The spacecraft's computers also revealed the limits of time. Voyager 1's main computer systems were designed in the early 1970s, before the age of laptops, smartphones, or even modern digital storage. Its memory is measured in kilobytes, not gigabytes. Its software was written in an era when punch cards were still used in programming. Yet, remarkably, these systems continue to operate, executing commands sent from Earth with a delay of nearly 2 days. Despite these limitations, the mission continues to exceed expectations. Scientists had originally planned for a 5-year mission, ending after the Jupiter and Saturn flybys. No one truly believed Voyager would still be working after 45 years, much less exploring interstellar space. Every extra year of communication is a gift, providing new data about regions of the galaxy never studied before. But time is relentless. Power will continue to decline, instruments will shut down one by one, and eventually Voyager 1 will no longer be able to speak to us. When that happens, it will continue its silent journey, drifting endlessly through the stars. In about 40,000 years, it will pass within light years of another star system. Long after Earth has changed beyond recognition, Voyager will still be out there, an eternal traveler, its famous golden record. In the next section, we will explore that legacy, the golden record, a time capsule meant for alien civilizations, and why Voyager is more than just a scientific mission. It is a message of who we are. Beyond its scientific mission, Voyager 1 carries something deeply human, the golden record. This is a copper phonograph record, plated in gold, attached to the spacecraft's body. Unlike the instruments measuring plasma waves or cosmic rays, the golden record is not about science. It is about identity. It is humanity's message in a bottle, cast into the cosmic ocean with no guarantee that anyone will ever find it. The golden record was the brainchild of astronomer Carl Sagan and his team. They asked a simple but profound question. If another civilization were to discover Voyager, what should it know about us? Their answer was to include sounds, images, and greetings that represent the diversity of life on Earth. Engraved onto the record are 115 photographs showing landscapes, animals, human anatomy, and moments from daily life. Alongside the images are natural sounds, the crashing of waves, the rumble of thunder, the song of birds, and a curated selection of world music, from Bach to traditional folk songs. Perhaps most powerful are the greetings. Recorded in 55 languages, voices from across the planet say hello to whoever might find the spacecraft in the distant future. There is even a message from the Secretary General of the United Nations, a symbolic reminder that Voyager was launched not by a single nation, but by humanity as a whole. The record also contains encoded instructions explaining how to play it, including diagrams showing the position of our sun relative to nearby pulsars, so that any intelligent beings could, in theory, trace Voyager back to its origin. It is both a map and a message, a way of saying we are here, and this is who we are. Think about what this means. Voyager 1 is not just a scientific tool, it is a cultural artifact, perhaps the most distant piece of human heritage in existence. Long after its instruments go silent, long after Earth itself has changed beyond recognition, Voyager will continue drifting through the stars with the golden record attached. In a sense, it is immortal. The chances of another civilization ever finding Voyager are vanishingly small. Space is unimaginably vast, and Voyager is no larger than a small car. But that was never the true purpose. The golden record was a statement of hope, a declaration that humanity wanted to reach beyond its home world and leave a trace of itself in the cosmos. As Carl Sagan famously put it, the record says, "This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours." In this way, Voyager 1 carries not just data, but meaning. It is both a probe and a storyteller. And as it sails into interstellar space, it reminds us that exploration is not only about discovering new worlds, it is also about discovering ourselves. In the next and final section, we will reflect on Voyager's legacy, the limits of its mission, and why its faint voice still inspires us today. We will also invite you, the listener, to continue this journey with us. Voyager 1 continues its silent journey through the stars. Its instruments are aging, its power source slowly weakening, but its voice still reaches us, faint, delayed, but undeniably present. Every signal it sends takes more than 22 hours to travel across space before arriving at Earth. That means when NASA listens to Voyager, it is listening to the past, to a message that left yesterday, crossing billions of kilometers of emptiness. Eventually, sometime in the 2030s, Voyager's power will run out. One by one, its instruments will shut down. Its signal will fade into the cosmic background, leaving only silence. But even when that day comes, Voyager will not be gone. It will keep moving forward, endlessly, circling the galaxy for millions, perhaps billions of years. In that sense, it is humanity's first true interstellar traveler. Why does this matter? On a practical level, Voyager 1 gave us invaluable knowledge. Measurements of Jupiter's radiation belts, stunning close-ups of Saturn's rings, evidence of active volcanoes on Io, and now direct data from interstellar space. These discoveries reshaped planetary science. But on a deeper level, Voyager has become something far greater. It is a symbol of our curiosity, our resilience, and our desire to connect with something beyond ourselves. Consider this: all of human history, all wars, all art, all inventions has taken place on a pale blue dot suspended in the void. And yet, from that dot, we managed to build a machine, launch it into the unknown, and teach it to speak across light years. Voyager is proof that we are are capable of dreaming bigger than our immediate struggles. It is also a mirror. When we look at Voyager, we are really looking at ourselves, at our need to explore, to communicate, to leave behind a trace that says we were here. The golden record is not just for aliens. It is for us, a reminder that humanity is one species sharing one fragile world. One day, long after we are gone, Voyager will still be traveling, carrying the sounds of Earth, our music, our greetings, our laughter through the silent ocean of stars. And that thought alone is enough to inspire wonder. This is why Voyager matters. It is not just a spacecraft. It is a story, a message, and a hope that echoes across eternity. New Benthihan Trends Ca Voyager AGCM Hai Non Like Chia SB Video Bahung KN BrightBoundX G Kung Chung Ti Kum Pha Them New Kao Chien Koa HCCK Thukuk New Luting Hasia Bin Chin Lloyd On Luk G Chung Ti Tip TIC Mang Han Nung Nui Dunch Lung The AGCM Hai Town Tung Ngoi Kia Voyager 1 VN Hengbe Mang Theo Li Chow Ti Trijate But YK Chung Tanungi Y Le Kun Ko The Kung Now Tip TIC Han Tren Kum Pha Bin Tri Thick The SS to Mo Biek Ti Ton